Hi, everyone. Thank you for being here, first of all, because I know it's very late. I'm not going to be extending this talk anywhere near beer or closing keynotes. That's a promise. So whatever isn't delivered just will happen next year or something, which is kind of the point of this talk, continuously delivering, continuous delivery. So first, something about me. At this moment, I just started September 1st at Schuberg Phyllis, which is a company that started from infrastructure, but found out that the world is changing and everything is moving to code. So coming from software development myself, I'm going to try to help make the journey to adopting more cloud native, also serverless and all the kind of cool stuff. So I'm very excited. And the customer director is the title I have officially, because I have to have some kind of business card, but it's a very cool company, so everybody can shape their own role, because they believe that everybody have their own strengths and weaknesses, and you have to do what you love, and that's something that really resonates with me. I'm very excited by working there. Before, I was head of development at ANVA. This is a company in Holland that is maintaining 70% of a market share on insurance software. It's an IT vendor. And we did all the cool stuff over there. We went to microservices, continuous delivery, immutable infrastructures, all running on AWS. And also made our way into self-steering teams, which I was discussing before for who was present. Before that, I was in a head of IT at an insurance company, also going into microservices and also into continuous delivery. And at that insurance company is where this talk for the first time kind of came to exist. Because what we had was, we thought microservices are cool, and we are going to deliver a lot of microservices. We came to learn that we need a big framework, so we were kind of working for a year, and we had about 200 components and another 100 applications, and we didn't go to production. Not yet, after a year. So then someone had a bright idea. Let's try to use this stuff. And we thought, yeah, that's a good idea. And then we had to manually bring 300 things to production. So we were screwed. Then I kind of thought, well, who's going to do this? And everybody was, well, we're going to production, so we're making adjustments to our code. And I thought, okay, I'll try to figure things out. So that's how I met continuous delivery for the first time. And it has been a very happy journey for me, because I learned a lot. And it changed a lot of things for me personally as well, in how to prioritize in life and how to actually be satisfied with small results. So I like it very much. And I have been programming since 2018, but I did see the talk of Feline, the closing keynote. So I can say I have been programming since 2000, because I have done a lot in Excel and a lot in MS Access. So I'm very happy. And you can all say, that's not real programming. But then she will get mad and hunt you, she promised, right? But she has already left. Well, there are some handles. So then again, about customer satisfaction, the company I work with, just a brief introduction, we do mission critical solutions. So for governmental, for instance, the Ministry of Finance or the energy providers, this is all mission critical to not only that company, but to Holland, the country I come from. Because if there is no energy, we all have a big problem. And we actually first started hosting that software, then started our own cloud. So we have our own cloud. And there is a market for that for companies that are very reluctant to put things into other countries. For instance, our government is. So that's good. And now we're thinking of going to cloud native and serverless, as I said. So at the moment, I'm in a team where we're building a bank without any servers and without any of our own cloud in use. And that's very cool. And we have a very high NPS, so that means that like from every 100 customers, 93 promote us, and only 7 are neutral, and that's really very cool. So I'm very happy to work here. And oh yes, we're hiring. And we also make sure you get a safe landing in Holland, and we are at Schiphol, so you just have to take the plane, and then you're right there. Okay. something about continuous delivery. I'm going to put this in 3 kind of chapters. So what's the business case for going to continuous delivery? So why would you want to do this? Then what is it actually? And thirdly, how can you deliver continuous delivery? The last stop is the practical approach, and I will work my way through the first ones as briefly as I can, but I am never brief, so don't expect too much. This is what I hear a lot. We want to do continuous delivery because we want to go faster. Anyone here is doing continuous delivery at this moment? Okay, that's nice. Anyone does that to go faster? That's not the main driver. I do see a lot of misunderstanding on this field, so that's why I'm going to stress this a little, because I did hear this at clients. Also, clients were asking us for, let's go to continuous delivery because we heard it goes faster. So what they think is that you will do the same amount of work in 10% of the time, which would be so awesome. But it isn't going to happen anywhere in the near future. So no, that's not the main driver. And if you don't get this misunderstanding out of your way, then you have this first disappointment born into your product with your clients. You don't want that. So try to explain to them what is your goal. So what is the goal of continuous delivery? Well, small things are simply easier to handle. So we have the Standish report, which has quite ridiculous numbers, where large projects only for 10% have succeeded, and 52% is challenged. The other ones just were never going into production. And small projects, 74% was successful. And that is because you have a much shorter feedback cycle. The complexity is much less. The amount of things you have to test, the amount of plans people are asking to roll back, everything gets easier when you're delivering small things. So that's one part. Then the second part is you need to test your assumptions early. So you need to shift left and get feedback very early in your software development process. That's not because you only make mistakes. It's just because we can't actually predict what users want. We are really bad at predicting what users want. So we think that what they say is actually what they want. And how many of you have been in a project where you followed the requirements, you delivered the requirements, and then the customer said, that's not what we wanted, right? The customer can't even know what he wants himself, let alone can we make assumptions about what they want. So the only way to test is by putting it into production and see what works for the customer. Test your assumptions early as possible. And then try to make them more perfect. The things that work only. And why is that so important? Also, again, from the Standish group, if you look at the stats of unused features, 64% of features is not used in large projects. So I think you should stop doing projects, right? Someone gave a hint on that. And if you do small deliveries and you can test what's used, then you can actually get rid of the stuff that isn't used. And if you think of software development lifecycle management, getting rid early of that stuff makes the complexity of your system so much less. It will also make all the other things go faster, right? If you get rid of those features that aren't used, you don't have to test them when you upgrade a version or when you have new vulnerabilities or whatever. If you diminish it by half, the complexity will diminish by far more than half. That's a feeling we all have, right? There is a certain point where it just won't fit in your head anymore. So try to stay below it. And then thirdly, it's about elimination of waste. So why should you talk about work you're going to do in a year? And I've seen so many plans where there were very long discussions about what we should do over a year. And we never went up doing it. And we had hours and hours of meetings because I was a manager. So that's what we do. And it helps a lot. Well, I worked at ANVA, at the company, and they had a kind of a meeting where they would prioritize all the things on their backlog, which is kind of a good practice, right? You need to know what you are going to do first. And there was a big discussion about whether a single item should be number 98 or 97. And we were doing about like 5 in 2 weeks. So it was very important to them, whether it would be 98 or 97. But it's work that's never going to be done. So get rid of it and focus on actually delivering value to your customers. So if you get flow, if you get predictability, you have to do a lot of less reporting. You have to do a lot of less long conversations about which one goes first. Because at the point where you're delivering number 97 and 98, if management is confident that you have you can do 10 a week because you've improved velocity somehow, and they know, okay, it doesn't matter because it will be delivered either this week or next week. So why bother talking about it at that point in time? That's where you want to be. So that's continuous delivery. And also take away the emotional cycle of manual delivery. Who does any manual delivery over here? Okay, do you recognize this? Like you have your target ship date and then emotionally you're already feeling kind of anxious. Then you're passing it. You do a lot of overtime. Emotionally you get to feel bad. It's stressy. You need to find ways to actually deliver. You need to take shortcuts. You need to include and accept technical debt in your code. You don't want all these things, right? So emotionally, you're feeling unhappy. That's not a pattern that's very healthy. So also as a part of well-being, it's much better to deliver every day and just go home. Not right after delivery, maybe. Just stick around for an hour, see if things go right. So the last thing, of course, agile. It's about enhancing value. So if you have a project and you deliver the whole thing after a year, then you can start using it after a year. And then maybe you'll use it for 2 years, so it has a value of 2 years. But if you deliver the most important thing after a month, then you'll be just using it 11 months more, which enhances the value. Probably also because then it's still relevant, because after a year, oh well, you should stop doing projects. So it's about constant change. To improve is to change, and being perfect is to change often. So continuous delivery is about how can we adopt a way to actually make sure that we can get constant change in the hands of the customer. And then you have these enormous great stats. These are in the book Accelerate from Jess Humble and I forgot the woman's name, I'm sorry. But it says, okay, the high-performing companies are able to deliver 200x times more and have these kind of shorter cycle times, which is ridiculous. And they will do it at a lower fail rate. So it's not about accelerating only. It's not about going faster, but paying the price of doing it at a worse quality. It's about going faster and also delivering a better quality. That's what the high performers are at. So it's not just about speed. Get it out of your head. So what is continuous delivery then, if it's not just about speed? Well, there are a lot of opinions on that. So we see people say, okay, it's mostly about a technology. Or no, maybe it's a culture. And I think there are a lot of opinions, and you can just read this at an easy moment. But you can say it's not about culture, it's only about technology. Then it's kind of like deployment automation. And AWS actually has a definition that suits that very well. You can also say, yes, it's about technology, but it's also about culture. Then you end up being somewhere in the Fowler zone, where he says it's about a close collaborative working relationships. So also the DevOps culture. That's the broad aspect, right? You can also take the minimal view, like, okay, it's CI with a little layer on top. I don't really like that one. I think it's a bit more. Or maybe it's a way of working, so it's not about technology, it's just about removing silos. And there are also definitions found on the web that will support that. I'm taking the one from Jess Humble. I will go very briefly about it. It's a set of practices and principles in software engineering, and it's aimed at building, testing, and releasing software faster and more frequently. And in the end, it's about delivering incremental changes to applications in production. So I think it's mostly about technology and a little bit about culture, somewhere in between there. Don't let it be too much about culture. I think it's really about code. And I shifted away sometime from that. But in the end, it's about automating everything you have to do to actually deliver the code you just made. So Never let the technology part be taken away from it. So then the small steps towards continuous delivery. Lesson number 1 is continuous delivery means you're building software. So please treat it as a software process. We've learned a bunch of things about how to make software. So you have to have agile principles, you have to have a backlog, you have to prioritize, you have to have minimum viable products. You can't build it all at once. You have to have someone with mandate to choose which things are important for business. So who is business for continuous delivery, right? These are questions, you have to address them if you're going to do continuous delivery. I've heard a lot of people say, okay, we're doing a project to deliver continuous delivery. We are going to do that for 3 months and then afterwards we're finished. You are never finished with continuous delivery. You have code in production, you have to maintain it. It will be in your company forever afterwards. And you also have to think about how am I going to continuously improve this? And also you have to make sure you push it out to production as fast as you can be. But because also this code has to be used in production just as well as your customer-facing code. It's no different. So how do you do that? You have a backlog, you have your minimal viable products. You can maybe use a lean approach to see where things are slowing you down in your company. You have to have some clear idea about where can we take our first steps. You can also use a maturity model. If you Google maturity models for continuous delivery, there are a lot. This is just an example. I don't have a specific opinion on which one is best. But it will also, what I find important about the maturity models is that there are different levels. And trust me, it's not good to be at level 5 for this activity and to be nowhere for the other activities because it will be inconsistent with each other. And we had problems like this, where we were able to release to production with just a push of a button, but we had no monitoring. So things crashed and we didn't know. So yes, it was very great that we had a fully automated pipeline, but without any monitoring in place, it was just dangerous. We were not going faster and giving better quality. We were just going faster and screwing things up. Don't do that. So try to actually grow this. Another example would be, this one is one of my favorites. You have to make sure that teams can release changes independently from each other. So what we had was some of the teams were very fast and they were able to go to production with just the push of a button. But other teams weren't. And then the teams that were fast said, yeah, okay, we are fast. You have to deal with your problems. We are not slowing down for you. Well, that didn't help the customer. So you need to actually go there together and help your colleagues to also make this journey, right? It's about optimizing the whole. Why is my clicker not working? Okay, apparently, after talking at conferences for 3 years, the battery goes down or something. Oh no, you just have to do your restart before you do your presentation for updates. Okay. The next thing is you have to grow together, as I said. Oh, sorry, it did work. I just had an update and it thought this was a good moment to restart. I didn't agree. So, as I said, you have to grow together to make things consistent. Otherwise, you get all these differences between the teams, and it won't help collaboration because people are getting to be unnice to each other. Some people are feeling like rock stars because they can go to production very fast, and others are trying to seek help and to find ways to also push out value, and they don't know how to do that, and they're seeking help. But the other guys are like, hey, we are going. So, yeah, find out yourself. We did. Okay, that doesn't help. So do some pair programming or mob programming on it, or actually help your colleagues seek the ways they, in their environment, because they have their own problems. It's not easy for them. In their environment, how can they actually also speed up? Because it will optimize the whole if you give that some attention. So this is practical step. You have kind of different systems. This is where I was at. Like now we have to deliver things. What do we all need? And what would be our first step, taking this maturity model into account? So you have maybe for some components your own environment, and each environment will have some kind of development and test environment. Maybe you have just one. And you have somewhere in your landscape something where it integrates all, and some acceptance testing and some maybe some production if you're lucky enough to work at a company that is in production. And then what you can do is you can add one single extra environment, which is for scenario and UI testing. That environment will allow you to say everything I can automatically test, I will put in here. And everything I want to still test manually because I have no test automation. That's mostly the starting point, right? Or too little test automation. Everything I want to test manually, I will still do here because this is my break in my pipeline. And what you then do is you move manual tests to your integration. And you can do that step by step. So that's continuously delivering, right? And every time you move one, you don't have to do it manually anymore. So you're actually delivering value by moving the first test from this environment to this environment, and you can go a little bit faster every time you do that. So what you do is you add tests, and you also add a lot of metrics. A lot of metrics like what's my code coverage, how is the health of my applications doing, stuff like that. You really want to know this about your environments because previously you were working in those environments, and you have to consider you are going to the point where you're not opening those environments anymore, ever again. So you need to be ready for that. You have to have push messages when something goes wrong. And also you need to add a lot of monitoring. That's important because otherwise your test layer will be too heavy. I will go into that later. And you need to add reviews. Because previously when you went to production once a half a year or something, people were doing code reviews at a certain frequency. And now anyone can push any line of code into production with just the push of a button. That also makes it dangerous security-wise. If someone, man-in-the-middle attack, you could be very exposed to that if you don't have an obliged 4i principle. So that's the peer reviews. What we did, we used UpSource at that moment at the insurance company. We did not use that one. At my current company, we use Sonar Lint, which is a new feature on SonarQube. Both have the benefit that they run inside the IDE, which means you can see the comments of your colleagues in the context of the full code. And that's what they found quite a benefit. So look at the requirements, find something to do this. We added monitoring. We used the elk stack at the two previous companies, and that was very fine for us. And at this moment, we're using Datadog, which is also very fine for us. So, but find a way. Most important thing about monitoring is you can't just put it on and be ready with it. You have to customize it. Because if there is so much data that the information gets lost in the amount of data. So be sure to have some monitoring just at the basic level, but then you have to have someone thinking about what's the information that is of use and make sure that it's in there and make sure that it's relevant and it's predicting what will happen. Because if it doesn't, nobody will ever look at it. And then it's just someone who's setting check, I have monitoring, so I'm ready. No, you're not ready unless you're using it. Also test your assumptions on this point. And you have to have some kind of static analysis to make sure you're maintaining a certain code quality. So code quality, well, we all know this is a screenshot of SonarQube. I think it's familiar for most people, right? But anyone is good. It's about talking about what is quality for us. So again, it's not just setting check after, yes, we have in our pipeline some kind of static analysis. It's about actually using it. So find ways to discuss what is quality. There were so many ignores on warnings in Sonar, and they were kind of fading the real information, like the warnings you really did want to use to actually achieve a better code quality. So you have to think about your rule set. You have to think about why is this rule included in this static analysis tool? What's behind it? If I don't understand it right now, I have to make sure I understand it before I proceed. I can't just set the ignore button or ignore the warnings. Sometimes there were like 2,000 warnings, people were just ignoring them. So don't be like that. Try to adjust them. So adapt to your needs. Make logging, static analysis, and scans and checks very relevant for your situation. I'd rather have you log too little, but have all the information be relevant, than that you just put a log on everything, because it won't help you. If you're at this stage where you have like a basic layer, then you can proceed and also try to use context if you're going to do this, because your company has your own needs. So don't just use all the buzzwords because people you went to school with use A/B testing. It's very hipster, right, to do so. But that's kind of part of an experimental approach. And maybe you're not in a company that needs an experimental approach. Because, for instance, you're giving business-to-business software where you can actually talk to your customers. So they can just sit next to you and give you feedback, for example. So try to find the ways that are important. Try to find the things that are important to you. So right now we are working on mission-critical software. It's very important for us that it's secure. So that will probably be one of the first things we're going to adopt in our pipelines, because it's more important than having blue-green deployments, for instance. So think of the context of your company and think, what am I going to do next? Have some prioritization. So number 2, testing requires architecture, design, and prioritization. I can't pronounce that word. So testers aren't developers, and developers aren't testers. And they will never be. They can learn a lot about each other's work, but mainly they are different characters. They look at the world differently. But what you do need is they need to help each other, because they, given their unique perspective, they know things that will greatly help each other's work. We've all seen, I guess, the test pyramid, and it says you have to have a lot of unit tests because they are fast and they are good maintainable. Then you have to have some component tests, integration tests, and API tests. And then, as little as possible, you want to test your UI, because those are the slow tests and they are very costly to maintain. And I found from some lessons that there is kind of a different approach, because this will not help you to the max. What I did, I took this own model and I thought the main thing is it critical to your business? Is it high risk? So if it's endangering your business continuity, or if it's code that's in development, or it's code that just has a smell on it, it will be more important to test those lines of code than the ones that were just sitting there, less important, not in development. So you need to prioritize given business context again. And you need to do those things sooner in your pipeline. So what we did at the previous company which made insurance software, we said there is a full test set. And in the first phase, you can select which ones to run. Because if we run the full test set, it'll take you about 2 or 3 hours to get feedback. While the person who had developed knew which tests were more relevant. So they said, okay, I'm going to select these 10 tests, and I get feedback within a minute or half a minute. I know if I messed up. And then in the next phase, I'm going to run the full test suite, probably not having messed up anywhere. So you have to think about these concepts. Make sure you get speed in your feedback. And also very important is monitoring is also a step in testing. So we see these quotes like, I don't always test my code, but when I do it in production. Testing in production. And I've had a lot of feedback, like people saying, yeah, I can understand how that will be funny for a small web shop, but we have a professional company. We can't test in production. We have banking software or insurance software. Well, surprise, there are a lot of features that aren't essential for your company. And that will probably make sure that not a project, but every small delivery will still be very hard to deliver because you have such big test sets. We actually had a simple change in a name that cost the developer like a minute. And then we had to adjust tests. Also because they were not good architects. But the testing, the adjustments, would cost us about 8 hours. So that's where your business case will also fail if you're in that situation. So you don't have to test everything. It's fine to actually, for instance, if you're developing for mobile, then you see a lot of emulators that will kind of try to see, does it work on every phone as part of your pipeline, which is nice. But after you deliver it, there will already be a next phone or an update on the platform. So essentially, it's also useless. If you just do these tests in production, that's much more valuable. If you have the ability to restore service very fast. If that's a project of a year, then you're still screwed. And then you should definitely test it before you go to production. So maybe you can work on that. You also have to make sure you have maintainable tests. So maintainability, developers know what that is. They've tested on this a long time. Testers did not have to learn this concept as part of their jobs. Help them, please. So this is what Seb Rose said about it. You have the imperative style and you have the declarative style. So in this style, you say, I have some user account. And I'm providing an acceptable username and an acceptable password, which is somewhere else in a library. That is kind of a good practice. For every programmer, it will be very natural to do so. Our testers didn't. They did not know about these concepts of libraries. So you have to learn them to actually take this style. So this is what it worked like in the end. We were all collaborating, developers and testers together, to actually try to make good maintainable test code. And they helped each other out. It was very good. Also, make sure you collaborate with business. There's also a nice example to that. There was this guy who made 10,000 tests on a live premium calculator. So we had live premiums, found it very important that they were correct as an insurance company. 10,000 tests on it. And then we were running it every time, so we thought we were safe. Until a domain expert opened the test set. And he found out that 2/3 of the tests were situations that could never happen. For instance, an 80-year-old person who would ask for an insurance with a duration of 80 years. Well, we would never accept a policy like that, because people don't tend to get 160 years old, right? So that was not a real-life situation. So what we learned from that is we removed the 2/3 of the tests, which were actually making sure that we... Oh no, this is so bad. Yeah, okay. I'm going to do the next story by heart or something, because it's going to restart. I don't understand why it does that. I'm really sorry. I just have a new computer. Maybe it'll restart somewhere in the background. So make sure you collaborate on tests. Also, because what we learned is when you showed your users what you've already tested, that's information they didn't know. They don't have access to those test automated scripts, right? So they're doing their own tests under the assumption that we didn't test it yet. So you have to show them, like, okay, we already tested these things. So the only thing you have to test is everything we didn't automatically test. Before that moment, there were users actually going through tests on the live premium account, on the calculator. And what they did, it's at 29%. And what they did is they actually tried to do 200 situations where they entered parameters and then checked if the live premium that was returned was the correct premium. It took them a week. So there was a week that was blocking us to go to production because they thought we didn't check if the live premiums were okay. We did. So the next step would also be about test automation. Your infrastructure is going to code. So as any code, you also need to test that code. And I hear very little practice of people doing that. So we're making all these deployment scripts and all these configuration scripts, and we're not testing them, which is against what we're doing everywhere else in the field. So try to make some test scripts. It will be on the edge of technology, but it's very cool to do so. For instance, what we had, to do tests, we had to be able to remove customers from our database in test. This was very forbidden to do so in production. You never remove the data of a customer. So what we included in our code were things we called rabbit holes. We thought we'd give them a flaky name so that everybody would know, don't use these things in production. These are rabbit holes. They are bad. And then in configuration, we said whether they were on or off. So naturally, in test, they were on, and in production, they were off. Until one day, someone screwed up a script, and they were on in production. We had big data issues. So what we did then is we added tests to actually check whether they were off and on in the right environment. Both were important to us, because if they were off on a test environment, then all our tests would fail and people would be called out of bed for nothing, because it was just because the tests weren't having access, which would also be bad. I'm trying to anyway. I thought mainly this time I'm going to have fun, because I'm always very nervous, and I thought I've had like 3 years of experience, so maybe I could use this talk to have fun, and then this happens. I hate life. Yeah, I also hate Windows. I don't know which one I hate more. Oh yeah. Now my face is also red. I know that. I can feel it. Why isn't it starting up anyway? Okay, lesson number 3 is, I know this one. Oh, wow, it's starting up. Almost, no. Okay, lesson number 3 is, branching is your new mother-in-law. You don't go there unless you're forced. Why is that? Because branching will actually extend the moment you're going to integrate. So what happened at a lot of our code was people were knowing that when they would push their code into the development environment, then it would naturally proceed into production, being used. And then they thought, well, then I have to think about how to make my code so small that it can actually go into this pipeline and not break anything. Because otherwise, people say I can't go home. I have to fix the build. And I want to go home. That's very valuable to me. So what I do is I don't push my code to production. So I have continuous delivery with long-lived feature branches. Okay, that's not continuous delivery. That's kind of not the idea, right? So we kind of messed up over there. Let's see where I am at now. This is a totally different presentation. Oh, this is definitely nightmares. Click to add the first slide. Oh yeah, that would be a good plan. Okay. I'm very glad you're also supportive. Okay. I promised I wouldn't keep you from beer, so let's just have a break or something. Okay, so this one. So branching will actually extend the moment you're integrating, right? So don't do that, because it's kind of against the idea. You need to just, it's tough, but you need to learn the ability to break things into small things. And it kind of feels uncomfortable, but you're only going to learn it if you're doing it. So don't extend it by taking long-lived feature branches. So there actually is kind of a funny story. I don't have time for it, but I'm going to tell it anyway. It's about, you know Sander, right? He did the keynote. So I was working at this insurance company, and then the director said to me, okay, I think we have a problem. So I said, okay, tell me. Actually, developers can work on source code. Yes. And they could also probably work on the same part of the source code individually on their own computer. Yes, that could also happen, theoretically. So what they could also do, he said, they could make adjustments, and then they will be both on an old version, so either one checks in first, but then the first one checks in, and the second one is missing the change of the first one. Yes, that might happen. Okay, so I told him about that we merge. And then they said, yes, okay, but those stupid developers have never thought of the situation. Maybe they can merge, but they've never thought of the situation where they push to production, or they push to integrate, and then it's checking whether there are merge conflicts. And while it's checking, the other one pushes to go to integrate. And then the software won't deal with it. So I have a very good idea. We're going to build our own version controlling system, he said. Well, being a company with few developers. I didn't think that was the best problem ever. That's kind of the worst not invented here syndrome ever, right? So what we did, we made a checking head. And we said, you can only check in, because we didn't want to build our own version controlling system. You can only check in when you have the head, to make sure we don't have any merge conflicts. That was great. And he has the check-in head, so he's going to try to push something to production now. And we just made fun of it, of course. But what I learned was actually there was some truth to it. And that's only reached me until recently. Because what did happen is we have some kind of problems coordinating all the releases and deployments. So at my current company, it led to actually us slowing down to be able to deal with this coordination. So we were at a pace where we were delivering every 2 weeks. And now we're delivering 7 times a month. Because there's holidays and all the teams have different occupations. So 7 times a month. And that's the result of continuous delivery. I didn't think we improved, right? So, and there was also some truth to it. Like we had this team and they had a production moment. And then they said to the other teams, well, don't do anything in the pipelines. Don't push anything because we're going to production. And we need to make sure that there are no changes screwing up this production. So actually, we had kind of a virtual check-in head. And we had a lot of work talking to each other, making arrangements, making other people pissed because they said, I can't get my check-in because you are screwing up, basically, because you are so dependent from my pipelines that you can't deal with it. So you have to fix those things. So again, one of my favorite is, make sure you can actually deliver code independently from other teams. Because that will eliminate a lot of waste in your process coordinating those releases. That's a very important activity and it's understressed in the industry, in my opinion. And deployment is not the same thing as releasing. That's also very important. Everything Facebook will release in next year, I heard Jess Humble say this, I can hardly believe it. But he says it's already in production. So they are already testing it somewhere. It's not visible for everyone. So when you do continuous delivery, you're actually putting things in production. Doesn't mean they are visible for customers yet. And that's the part where it's kind of strange because we want to test our assumptions and we want to have usage to actually know whether we did a good job, right? And then we're hiding all these features behind all these switches. It's kind of a contradiction. So still, don't be annoyed. Try to find out why are we doing this. Give the business some time for education, some time for actually having a contract before exposing a feature. It's nice to make money from it, somehow. Also give times for marketing. Maybe they will have a big launching site or something. So there are other processes besides delivery. And we need to make sure we can deal with them. So that's why I made the shipping delay pyramid, because everything is a pyramid over here. And I thought, what you can do to make sure you don't have to delay your shipping or you're able to delay your shipping. Well, first of all, make sure you're doing a lot of co-creation, having a lot of pre-acceptance. So don't first get into shit and then solve it. Make sure you're staying out of it. If you're delivering something that is kind of like smelly, get your domain expert in the room and ask him. It will get you a lot of less negative feedback. So if that's not working for this individual feature, then try to have everything arranged back-end, but have no front-end path, so you can't reach it. That's the easiest way. You can do all these things into production, back-end components, and then at the very last, you actually make sure you can get to all those functions by having a button or having a form or whatever, right? That's easy. Then you can do some feature toggling. You can do things behind switches, but there's a big downside because you're adding a lot of code that will be obsolete in the very near future by doing feature togglings. All these if-then-else statements. And it will make your software very bad testable because you have to test your software, theoretically, nobody's doing that, with all your switches on, all your switches off, but also every option in between. So that's 2 to the power of n, right? And that will grow out of you very fast. So you need to be careful with feature toggling, and you need to clear them in production after you have put them on and you want to keep them on. And then lastly, branching. Keep that in mind. You don't want to do that because you're extending the moment of integration. I'm not saying, as some people, like it's all bad. If you want to make a big library adjustment and you try to do this step by step, well, the overhead will be much more than having a branch just do it. So sometimes it can be the way to go. So what we developed was our own release strategy. And we said to actually make sure we can delay is we first do the full process of acceptance by a team. So that's the whole pipeline with your unit tests and all the other tests. And then at a certain moment, the team says, for us, it's okay. We think we are finished. And then we go to a rehearsal environment where customers and our own support departments could have like a week time to test the integration with their own systems, because there is a world outside of ourselves. So they needed some time for that. Then we went into a canary production environment, or this was the plan. We didn't deliver that yet. I went to another company. And that will make sure that we had less impact if we did screw up. So if you're releasing to all your customers at once, then the impact will be very big if you messed up somehow anyway. So what you can do is try to limit this impact by having one additional environment and having some people agreeing on being in this environment, because that will help you to get feedback from a small set of people. So lesson number 4. I'm going to hit on this very briefly because I ran out of time. You're only as small as your MVP and as agile as your roadmap. So we have discussed all these measures to actually make sure you can deliver things incrementally and very small. But if business is asking something that will just take you a half a year to build, then making it deployable every day is actually only overhead. You're not getting any value from early value delivery. You're not testing your assumptions. You're not getting feedback from real usage, right? So you have to talk to business and make sure they will be aiming at small deliverables. And that's kind of a hard process, I found out. It's hard to change these things because they have been accustomed to having extensive planning, like these roadmaps that will have a full year of planning ahead. And they also announced over here, like, okay, in 7 months we're going to work together and deliver software. They never asked for an impact or anything. They just said. So that's putting us down, putting down the experimentability of our approaches. So the result was we had burn-up charts. This was from a real project where the amount of work we had to do just kept growing, because we didn't learn. We didn't allow ourselves to learn which things were hard and which things were easy, and scope was already fixed. So we didn't get any feedback from production because scope was still fixed. We couldn't go to production. What we did, we kind of reinvented this. We had this portfolio management, and we said every idea goes into this big box, this big container, whether it's big or whether it's small, because business is not yet able to make things small. So we will help them. We had this board. There were also IT people in it who were kind of used to making things small. And then we said, okay, we have a few options. Whether it's small, whether it's big, doesn't matter. Some things are just a bad plan. We say no. We have a minimum of time spent on those ideas, because, well, this was a very lightweight manner of putting things into discussion. Then we said maybe, but we won't discuss it until 6 months. So yeah, it has some value, but we're not going to do this in the near future. So we stopped talking about it right at this moment. We found out that I think 90% of these were obsolete after 6 months. So that was very valuable, not spending time on things. Then we did some things. We said, okay, we need to make these things smaller. So we need more research to actually get a better understanding on the issue, or to see ways to make a smaller MVP. And then lastly, after making them small enough, we would say yes, or yes but later, within 2 months. So we maximized the time we spend on things we were actually building, because those are the things that actually have value. And this is the way we took business along. So speed of delivery isn't the answer to life, the universe, and everything. It isn't. So don't get hurt speeding up. Integration of security in your pipeline is very important. If you just go faster and you're not making sure that you have a lot of security tests in your pipeline, then it might be that you have such critical vulnerabilities that you are just out of business. There's a lot of examples from that. So look into security measures that you can integrate in your pipeline. That's a different talk. So I'm not going to enter into it more. But there is a full world of actually abuser stories, for instance, where you have custom scripts to test against a story like, as a hacker, I would want to have access to all customer data. And you can actually integrate those tests in your pipeline, just as your functional tests. You can also look into hack yourself too. I won't be the one to say hack yourself first, probably you've been hacked somewhere. But it will give you some insights to actually try to do this in your own systems, because people are not always aware of the vulnerabilities, and you'll get a shorter feedback loop if you're testing yourself and telling the programmers, the developers, like, okay, over here is a vulnerability, it's entered in our system. It will grow awareness if you do this. I will skip this one. For auditing and compliance, we also kind of reinvented these projects where we had these big rollback plans and we had all this compliancy to deal with and was slowing us down. We sat down with them. We said, okay, we're going to a new world. Help us, please. And they did. They said, okay, if you can assure that only green builds go to production, so if a test is red, there's no ability to actually push it to production. If you have a 4 eyes principle on all your code, if you have tests on, and also if you assert the code quality, and also if you can guarantee the value of your tests through, for instance, mutation testing, and if you take everything into version control, then you don't have to file any report ever again. So we were very happy because that was doable for us. So talk to your auditors, talk to your compliance officers, because they will actually help you to move forward instead of blocking you. It's a very important talk to have. And also it will change leaders, because there was an example of the director of the company who saw everything get self-steering and everything was happening autonomously. And he kind of lost control. He felt, I'm not knowing what's going on anymore. So what he did, he took a chair and he went to sit in the middle of all the teams. And he said, maybe I'll hear something now and then because I'm lost. Everything is going on and I don't know what anymore. So he sat there. It's kind of amusing. Now, the last lesson is customers don't actually want continuous delivery most of the time. And that's about legacy code and broken trust. This is a count of the line of code at the IT vendor. So we have like almost 10 million lines of COBOL code and almost 3 million lines of PHP. And that gave us a very bad releasability of all our software. So people thought, they said to us when we had the idea, like, okay, we have a great idea. We're going to release more often. And they said, you can't even release 2 times a year. And you're going to increase speed. Do you know how much trouble we have actually dealing with all the mistakes you're making? They weren't very enthusiastic, to say the least. So what you need to do is first improve, then accelerate. Pull, not push. And explain your goal. Just explain why it's important to go faster. Because if you're delivering smaller, it'll get easier. They don't know this out of themselves. We didn't know for years. So if you don't tell them, they won't make this up by themselves. They're not experts. So sit down with them. Just to wrap it up, you're building software. So treat it as a software process. Testing requires architecture, design, and prioritization. Branching, don't go there. But do look into ways to delay your shipping. You're only as small as your MVP and as agile as your roadmap. Speed of delivery isn't the only thing that counts. There is value in all the processes surrounding software development. And also customers don't want continuous delivery, so take them along in your journey. That's it. Thank you for your attention. Sorry I'm late.